let's go straight into an example. So we've got the integral of x squared ln x with respect to x. Now, as you can see, we've got two functions of x. We've got x squared, so let's call that f of x, and we've got a different function of x, ln x, so g of x. Now, because we've got two functions of x and they're being multiplied together, this means we need to use integration by parts. Now, there's a standard formula. We have the integral is equal to u times v minus the integral of v multiplied by du by dx. Okay? Now, in order to solve this problem, we need to find what u is and we need to find what v is. We also need to find what du by dx is. Now, the most difficult part with integration by parts is knowing what to set as u. So I'm going to give you an acronym, and that's LIATE or LIATE. So we've got any logs, any indices, any algebra, any trig functions, and then any exponential functions. Okay, so this tells us what order to prioritize what we set as u. So for example, in this case, we have a log as part of the product. So log comes first in my acronym. So I'm going to set u is equal to ln x. And I'm going to differentiate that. So we get du by dx is equal to 1 over x. Then next we set, well, dv by dx is going to be the other function of x. So in this case, x squared. So we want to integrate dv by dx. So we get, well, we need to add 1 to the power and divide by the new power. So 1 over 3 x cubed. And technically there will be a plus c, but that's not important for these types of questions. Okay, so now all we're going to do is replace the letters with our new functions. So let's start off with u. Well, I know that u is ln x. V, well, we just found is 1 over 3 x cubed. Minus, now this is a common mistake to forget the minus sign. The integral of, again, v, 1 over 3 x cubed. So we've got our v. And then we also want to substitute in du by dx. So times by 1 over x. And then all of that is integrated with respect to x. So let's tidy that up a bit. We get 1 over 3 x cubed, x cubed ln x, minus, now we can take out any constants from the integral. So we get minus 1 over 3 times the integral. Now we can also cancel out by a factor of x. So that's x squared. So we get the integral of x squared with respect to x. Now this is the same as what we done earlier. So 1 over 3 x cubed ln x. Now we've already integrated x squared, so that's going to be minus 1 over 3. Now that integrates to 1 over 3 x cubed again. And let's not forget to add our constant of integration, because this is indefinite integration, meaning we have no integration limits. We're not integrating between any 2 points. So let's tidy that up even more. So we get x cubed ln x over 3 minus 1 over 9 x cubed plus c. And that's my final answer. Okay, so let's go through another example now. So this time, let's try some definite integration. So I want to integrate between 0 and pi. So definite integration, meaning I've now got some limits of x sine x with respect to x. Now again, you can see we've got two functions of x. We've got x, so let's call that f of x, and we've got sine x, so that's my other function of x. Now these are being multiplied together, so this tells me I need to use integration by parts. Now I've got a standard formula for integration by parts. That tells me that my integral is equal to u times v minus the integral of v times du by dx, and all of that integrated with respect to x. Now I need to find what u is, v, and du by dx. Now let's use my acronym again. So LIATE. Now I can see I haven't got any logs in my integral. I haven't got any indices. I do have some algebra, so that's x. But I also have some trig in sine x. But in Lie 8, a comes before t. So I set my algebra, so u is equal to x. Then my dv by dx is going to equal to sine x. So let's differentiate u. So du by dx is equal to 1. Let's integrate dv by dx. Well, we've got sine x. Now, it's always quite confusing knowing whether sine integrates or differentiates to positive or negative cos. So let's have a trick. So if we go clockwise and we differentiate, we get that sine differentiates to positive cos, but cos differentiates to negative sine. Now if we go anti-clockwise, we get that cos integrates to plus sine x, but sine x integrates to negative cos x. Okay? So using that, we can see that sine x is going to integrate, so anti-clockwise, to negative cos x. So that's minus cos x. And again, technically there's a plus c. We just won't use it in these questions. So now I've got my u's and my du's by dx's. So I can substitute that into my general formula. So I is equal to u, so x times by v, which is minus cos x, minus the integral of my v again, which is negative cos x, times by my du by dx, which is 1 with respect to x. Let's tidy that up. We get minus x cos x, but this time we have some limits, so let's not forget that that's between 0 and pi. And again, we've got double negatives, but I can also take my constant outside the integral sign. So minus and a minus is going to make a plus. The integral of cos x with respect to x. And then again, we've got my limits, 0 and pi. So we've got minus x cos x plus, well, we're integrating cos this time. So let's have a look. Cos, if we go anti-clockwise to integrate, well, that's a plus, so it integrates to positive sine x. So we get sine x between 0 and pi. Now there's no need for plus c because we're using definite integration since we have limits now. So if we evaluate these limits, we get minus pi cos pi minus, well, if x is 0, then the whole bracket will become 0, plus sine pi, take away again, well, this time it's going to be sine 0. Okay, so we've just replaced the x's with our limits. Now you could put this straight into your calculator, but instead let's just draw some graphs to understand why we get the answers we do. So let's draw sine x first of all. So we can see that at pi, sine pi is 0. So that bracket becomes 0. We can also see that sine 0 is 0. So that's nice. That also becomes 0. That's clearly 0. So now we've only got to worry about the cos pi. So let's draw a cosine graph. Now at pi here, you can see that cos pi is equal to negative 1. So this is going to equal to minus pi multiplied by cos pi, which we know is minus 1. Therefore my integral is equal to pi. And that's my final answer.